symmetry property, there is one question, and we need to only just use the symmetric property to calculate the electric field, right? So let's say we have this pentagon, regular pentagon, and the charges on, so the charges on 4 points is given. All are plus Q, right? And they are asking what would be, so they are asking what would be the electric field at the center. This will be, so they are asking what would be the electric field due to, let's say this is E1, and let's say this is E2, this is E3, and this is E4. So they are asking that what would be the electric field due to all these charges. Okay. So what do we know about this symmetric property? Yes, Aisha.
E is 0.
So yes, so if it would have been another charge on this point, so if it would have been another charge on this point, let's say this Q charge, then all these, so electric field at this point then would have been 0, right?
Yes, sir.
So then E1 plus E2 plus E3 plus E4 plus E5 would have been 0, right?
Yes, sir.
So we have to calculate this part. So let's just keep that part in the left hand side and take this part in the right hand side. So this would be, right. So what does it tell? It tells that whatever the contribution this charge is making in the electric field, that is exactly opposite to these 4 charges that are contributing. Am I right, Aisha?
Yes, sir.
Right. So whatever, if we want to calculate the charge or the electric field due to these 4 charges, we can directly calculate the electric field due to the 5th charge, and minus of that would be the electric field due to all these charges, right?
Yes, sir.
So what would be E5? E5, let's say the distance is A. So E5 would simply be KQ by A square, right?
Yes.
So this would be the magnitude due to E1. Let's say this is E5. This is E2, E3, and E4. Right. So this is the answer. Did you understand this part? Yeah. So did you understand this part?
Sir, negative E5, right?
Yes.
In the last,
Sorry, your voice is not clear somehow. Yes. Yes, Aisha.
sir, it's negative E5, right? In the last.
Yeah. So negative E5 it is, but the magnitude is same, right? The direction is
Yes, sir.
negative, right? So forget about the direction. We only want to calculate the magnitude, right?
Okay, sir.
So magnitude is this, but the direction would be exactly. So let's say this is, let's say E1, E2, E3, E4 is, let's say some E prime, right? So this E prime is this, and this is E5. Okay. So this is the neutral point where your E is 0, right? Because this is the same E5 magnitude is same as E prime magnitude. Okay, Aisha.
Yes, sir.
Okay, so this was the question that we can use for the symmetric property, right? And now let us understand what is the variation of the electric field due to the point charge. Okay.
Yes,
So, so did you note down this part?
someone.
Okay. And please, I request you that whenever you have any doubt, please don't hesitate to ask, right? I'm telling you again and again, if you have any doubt, so be frank and ask whenever you want to ask. Okay. Don't hesitate.
Yes, sir.
Because if I'm not able to make you understand, then I'm not doing any justice to my job, right? So if you don't want to make unjust of my job, then you don't ask the question. But if you want that I do justice to my job, then please ask. Okay.
Yes, sir.
Yes. So whenever you note it down, please tell me.
Done, sir.
So we know that let's say this is some charge, right? And this is in the x-axis on the x-axis, right? And we are calculating. So let's say this is at the origin. Okay. So let's say this is at the origin. Some charge is placed, and we are calculating at this point, right? So this is ex. Okay. And this distance is x, right? So what would be the magnitude of the electric field, Aisha? This would be simply kq by,
KQ by
yes, kq by
X.
x square or x,
X square.
right? So this would be x square. So this is how electric field varies with this distance, right? So if I go in this direction, the electric field would be how much? So this denominator will increase, right?
Yes, sir.
So if this denominator increase, then this value will decrease, right?
Yes.
And if I am at the zero, so if this x is zero, very near to this nut chart, so this value would be maximum, right?
Yes, sir.
So the variation of this electric field in the x-axis, this is E. So this would be, let's say at zero, this is infinity, right? And then it is going to zero, right? So did you understand this part?
Yes.
Okay. Similarly, when we go in the negative direction, so let's say our x is in this direction, minus x, right? So the electric field will be in the opposite direction, which means that it will be negative, right?
Yes, sir.
So then this would be the graph. Understood? Any doubt in this graph?
Sir, could you repeat once?
Oh yeah. So let me repeat it again. Okay. So this is how the electric field varies, right? This is how
Yeah.
the electric field varies. And let's say if I choose some value of x. So let's say if I am calculating this electric field at zero. So something by zero. Oh, so let me use another pen. So something by zero is undefined, right?
Yes, sir.
So this graph shows that at zero. So this is at zero. This goes to infinity, right?
Yes, sir.
And then when I increase this value, let's say at 1. So at 1, this would be kq, right? And at 2, let's say that would be kq by 4, right? So this is decreasing, right? So this is decreasing, okay. And then what it does that it when I put this value to infinity, so something by infinity is how much? Yes, sir. Something by infinity is how much? So let's say that something by zero is how much? By zero is infinity, right?
Yes, sir.
So if I take this here and take this guy here, so this would be something by infinity would
0.
be right.
Yes.
Or you can imagine in this way also. So let's say that this is 3. And if I divide it by 2, okay, so this would be 1.5. And let's say if I divide by this 1000, right? So this would be 0.003. And let's say if I divide it by 3 by, let's say 0.0000, so this is 0.00003. So you can see that this is approaching 0, right?
Yes, sir.
So when this is denominator is a very large number, so that will approach nearly to 0, right?
Yes, sir.
So something by very large number is 0. Understood?
Yes, sir.
So from the initial point, this was a very high value, and then it started decreasing. Okay. So then, and at infinity, it goes to 0. So this is 0 line, and E is becoming, so E is becoming 0. Understood?
Yes, sir.
Similarly, in the negative direction, so at minus infinity, so this is minus infinity, so that would be 0, right? So E at minus infinity is 0. And it is increasing in the negative power, right? So it is increasing in the negative way, so this negative value is increasing, right? So
Yes,
at
sir.
0, it is becoming minimum, right? From the left hand side. Okay.
Yes, sir.
So clear, any doubt?
Yes, sir.
Yeah. So this would be the graph, right? So this is due to what charge we have chosen the charge to be positive. Okay.
Yes, sir.
And for the negative charge, you can imagine, right? So for the negative charge, this would be opposite. So whatever this graph was, this would be like this. Okay. So this is for the negative charge. Understood? This
Yes,
is
sir.
this is E and this is X. So this was the variation of electric field in the X direction. Okay.
Yes, sir.
Yeah. So did you note down this part?
No, sir. Not.
Okay. And then you have this superposition of electric field, right? We calculated the electric field due to this charge. So at this point, we calculated this was charge Q, and at this point, we calculated the electric field. So this was KQ by R square, right? And let's say R hat. So this was R and this is R. Okay.
Yes, sir.
Now, what happens when you have multiple charges? So we are calculating the electric field due to multiple charges. So that's when you learned in the Coulomb force, right? So force due to multiple charges was what? Do you remember?
Vector, sir.
Yeah, yes, absolutely correct. So vector sum. So similarly, the electric field would behave like the same way, right? So superposition principle, and this is electric field. Okay, so let's say you have this point, and these are the multiple charges. Okay, so this one, Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8, Qn. Right. So this one, So this is E1, E2, right? E1, E2, and similarly En. Okay, so the net electric field would be, so the net electric field on some point due to multiple charges would be the vector sum of the electric field due to the individual charges. Right. So your E would be E1 plus E2 plus E3 plus E4 and E. Okay.
Yes, sir.
So are you writing this?
Yes, sir.
Okay. So please note down this part, and then we will do one question, and then we will understand about the electric dipole. Right. So I'm hoping that I quickly finish this first chapter. So this first chapter is the biggest one, and the potential electric current and those magnetics is, so that those are very short.
Done, sir.
Done. Okay, so let us calculate. Let us do a question which is based on this idea, superposition principle idea. So let's say that we have this square. So we have this square and four charges are placed on this square. Okay, so on the corners, four charges. So let's say this is plus E, this is plus 2E, this is minus E, and this is minus 2. Okay, so four charges are placed and we have to find the electric field at the center. Right. So from the symmetry, you know that symmetry was applicable only when we have equal charges. Right.
Yes, sir.
So when we don't have an equal charges, then symmetry property is not valid. So we can't find then we have to calculate the charges due to this superposition principle. Right. So let's say this is O and we have to find electric field at O. Okay. So before I do that, so you tell me what is the angle between the diagonals of a square? What is the angle? Yes, do you remember the uh,
No, sir.
so okay, no worries. So so these are the diagonals, right? These are the diagonals of the square and they bisect perpendicularly. So these are perpendicular and they bisect, right? And also the diagonals are also equal. So all these are equal, right? So this is the property of the square. Okay.
Yes, sir.
So Okay, who left? Oh, the host left. Yes. And the side of this square is A. Okay, Aisha. So let's say, so this would be, so due to this charge, where would the what is will be the direction of the electric field?
No, which one?
Yes, your voice broke at some point. So
Now,
what
could
would
you
be?
repeat?
Yeah. So at AC would be that direction, right? Along AC.
Yes, sir.
So let me write with another color, right? So this is EA, right? We are only calculating the magnitude here. Okay. And so due to this plus 2E charge, the direction would be this, right?
Yes, sir.
So this is EB. And what would be the direction of the electric field due to this minus 2E charge?
Um,
Huh?
ED.
Yes. So again, in the direction of this T, right?
Yes, sir.
So this is EG, right? And what would be the direction due to this minus E?
Is EC.
AC, right? So this is A point, not E point, right? Yeah,
Yes.
yeah. So E, right? So this would be the direction, right?
Yes, sir.
So you see that these are in the same direction, so we can add EA and EC, right?
Yes.
So before we do that, let us find what would be the magnitude of EA. So magnitude of EA would be, so the magnitude of EA would be, what is the distance? Right. We have to find out the distance, and charge is E. Right. So this is K E, and this distance is what? So this is the diagonal. Right. This is the diagonal. This is A. This is A. Right, Aisha? So
Yes,
what?
sir.
So what would be this diagonal? Yes. This is 90 degree. This is perpendicular. This is base. So what would be this diagonal or this hypotenuse?
Mhm.
Yes. Yes. Your voice broke at some point. Yes. What did you say, Aisha? Yes. I
Tan value.
root of a square plus a square, right?
Yes, sir.
So this would be root 2a square. So this would be root of 2a square. So root 2a. Did you say root 2a? Because I can't hear you properly. So did you say this root 2a?
No, sir.
Oh, okay. So this would be root 2a, right? So root 2a and square, right? Because, oh, so this is not the, so this is the diagonal, right? This is the diagonal, and the distance would be this, half of this. Distance would be the half of this diagonal, right?
Yes.
So AO would be how much? So AO would be root 2A by 2, right?
Yes, sir.
So this is root 2A by 2. So this would be the same distance, root 2A by 2. This would be the same distance, root 2A by 2, because we saw what is the property of the square. And this would be again root 2A by 2. Right. So AO, BO, DO, and OC are equal. So this would be root 2a by 2 square, right? And what would be EB? What is EB? You tell me. What is EB? Electric field due to this point. Yes.
K2
Yes. K2E. Right. Absolutely right.
by root 2a by 2 square.
Yes. Correct. Yes. Absolutely correct. Good. Yes. So this is EB. And what is ED? ED is due to this charge. So don't forget about this negative sign, right? This negative sign is important when we are calculating the direction. So we have measured the direction, so then this is not needed. We are right when we are writing the vector part, then it is needed, but this is not needed here. Okay. So
Yes, sir.
so ED would be again how much? K2E.
2 by root 2a by 2 square.
Yes, correct. And then the last guy is left. So EC, right? EC would be how much? Due to this charge.
Ke by root
Yes,
2a by 2 square.
yes, absolutely right. So this we know. Now we see that EA and EC is in the same direction, right? So let's say that EA is, let's say, I hat and EB is also I hat, right? So EA plus, so we can add EA plus EB, right? This would be the magnitude, right? I'm writing EC, so EC, right?
Yes, sir.
So EAC would be EA plus EC. Okay, and this would be, this is how much? EA is KE by root 2A by 2 square, and this is KE by root 2A by 2A square. So this would be KE, this is 2A square, and this 2 goes in the numerator. And again, 4KE by 2A square. So this cancels, this cancels, and we have 2KE by A square plus 2KE by A square. So this would be 4KE by A square. Right.
Yes, sir.
And let us calculate this BD also. Right. So BD would be, so this BD would be how much? K2E by root 2A by 2 whole square plus K2E by root 2A by 2 whole square. Correct.
Yes, sir.
So this would simply be 2KE into 4 by 2A square, and then again 2KE into 4 by 2A square. So 2 cancels, and we have 8. EBD is how much? This is 8, and EKE by A square. Right, this is BD. Okay.
Yes, sir.
So now let us look in the diagram. So this is BD and this is AC, and the angle between them is how much?
90.
90, right? So remember the vector class. Remember the vector class that if we had two perpendicular vectors and the magnitude is given, right? So what is the resultant magnitude? Yes, do you remember this?
Yes, sir.
So the resultant magnitude would be how much? This would be root of EAC square and EBD square. Okay, so this would be, this is how much? So this is 4KE, so this is 16 K square E square by A4, and BD is how much? 8, so 64 K square E square by A4. Okay, so K square E square A4 is common, so we can take it outside the root, so that would be K E by A and square. And this is 16 plus 84, 64. So this is KE by A square, and this is 8, and this is 70. Right, so 78 is out. So this is 6. Okay, so root 70. Right, we can't take the factors out, so this is root 70. Understood?
Yes, sir.
Yeah, so this would be the magnitude of this electric field due to these four charges. Understood?
Yes, sir.
So where should I put the screen?
Yes, it is the same.
So is this okay?
Yes, sir.
Okay. And do you have any doubt in this question?
No, sir.
Okay. So did Mariam was there in the previous class? She was, right?
Yes, she was there.
Yeah, but okay. So then I will have to again repeat this, and this will take a lot of time. So what should I do? Okay, let's see. And you can see from this picture that the direction of the electric field would be this, right? Resultant would be is this direction, right?
Yes, sir.
Because this is the vector and this is the vector and this is the, from parallelogram's law, this would be the resultant vector. Okay, I should erase that because this, so sorry for my diagram because it got mixed up, right?
It's okay, then. No, sir.
Okay, so yes, is this good?
Yes, sir.
Whenever you are finished noting, please tell me, and then we will start the other topic.
Done, sir.
Okay, so then the next topic is electric dipole, right? Yes. So what do you mean by electric dipole? Let's say that up to this point we learned about the single charges, right? We didn't learn about the charges in pairs. So we learned about the charges in singled up when they were singled up. So those charges are called the monopoles, right? So when you have single charges, let's say plus Q and let's say minus Q. So these are monopoles, right? And when you have some charges in pairs, so these are called the dipoles. Okay, so dipole contains two charges with equal magnitude but opposite polarity. Okay, so this is the diagrammatic representation of a dipole. So this is a dipole. Okay, am I audible clear? Because it is
Yes.
showing that my internet is not stable. Yeah, so this is the diagrammatic representation of a dipole, right? And then you have this dipole moment. So this at the center, this goes from minus to plus Q. So this is the dipole moment, right? And this dipole moment tells about the strength of the dipole. So dipole moment and this tells about the strength of the dipole. Okay, and how it is defined? So this is the magnitude of this dipole moment is what is the separation? So let's say this separation is 2a and the charges are q. So this would be 2a into q. Okay, so this, and let's say when the separation is whatever. So this is separation into the charge, right? So let's say if the separation was d, right, and charges are plus q minus q. So what would be the dipole moment magnitude, Aisha? Yes. Aisha, are you there?
Yes, sir.
So let's say the separation is d, right, and charge is q. So what would be the dipole moment magnitude?
D into Q.
Yes, d to q or qd, whatever it is. Okay, so this is how we define the magnitude of the dipole moment. So let's do one question and let us understand how do we calculate the strength of the dipole. So let's say that you have this, let's say you have this charge, right? One charge is placed on the z-axis. So this is 0, 0, and let's say 3. And this is millimeters. Okay. So 003 millimeters, one charge is placed, and that is plus q. And minus q is placed at on the minus z-axis. So this is at 0, 0, and minus 3 millimeters. Okay. So this is minus q, minus q. right? So why this is 0, 0 here? What does this 0, 0 signifies, Aisha?
X and Y.
Yeah, because yeah, XY. This represent XY and this represent that this is only on the Z axis,
Yes.
right? So we have to calculate and we have to calculate this P vector. What would be this, right? So to calculate this P vector, we need what? We need this magnitude and we need this P direction, right?
Yes, sir.
So by looking into this, you can say that what would be the direction? The direction would be this, right? From negative to positive.
Yes, sir.
And what is this direction? Can you identify? This is what direction? So this is what direction? Z,
Z.
huh?
And Z direction. Z axis.
Yeah, Z axis. But what is the direction of the Z axis?
K
What?
cap.
Yes, K cap. So P hat would be K cap, right?
Yes,
So,
sir.
so this part is clear that this is K hat. Okay, now we have to calculate the magnitude. So this magnitude is, as you said, charge into separation. So charge is how much? Charge is Q and separation is, I should write the value of Q. So let's say Q is 10 nanometer, 10 nanocoulomb or microcoulomb, right? So Q is 10 microcoulomb and D is, so Q is 10 and micro is how much?
10 raised to -6.
10 power minus 6. And what would be this separation D, Aisha? So how much this separation would be?
3 plus -3.
Yeah, so 3 and minus 3, 3 minus of minus 3, right? So that would be
Yes.
6 meter, right? 6 millimeter. Understood?
Yes, sir.
So this is 6 millimeter, which is 6 into 10 to the power minus 3 meters. So this would be minus 6 and this is minus 9 and this is 60 and this is 10 to the power minus 9. So if I write 6, so then this would be how much? Minus 10 or minus 8?
10.
One is, so this was one extra, right? So 1 minus 9, right?
8.
Right. So this is the magnitude of this. So the P vector would be 6 into 10 to the power minus 8 and K hat. Okay. Understood, Asha?
Yes, sir.
Yes. So please note this down. And then we will calculate the electric field due to this type.
Done, sir.
Okay. Yes, so Sana has joined and she will take the again the class assessment, right? Whatever we have done so far, so So as you did in the previous class, right? So please be there just for 15 minutes, complete that test and okay, Aisha.
Yes, sir.
Okay, so let me just write what would be the next lecture, right? So in the next class, we would be we'd be learning about this electric field due to this dipole, right? So let's say you have this, we calculated the electric field due to some charge, right? So we calculated this electric field. Now we will have these two system of charges. Okay, so let's say you have this dipole and the separation is 2, right? So this is Q and this is minus Q. So we can calculate the electric field at 2 points. So one point would be at this line, right? One point would be at this line, let's say at this point, and one point would be at this point. Okay. Yes, Saad. Assalamu alaikum. Hello.
Walaikum salam, sir.
Yes. Yes. How are you, Saad, sir?
Alhamdulillah, sir. I'm good. What about you, sir?
I'm also good. Yeah. So did you watch that eighth episode?
Yeah,
And yeah, so it was again good, right?
yeah.
So and they just released the new season for the Bleach, right? 1,000 Year Blood War. So did you see that trailer?
Which one, sir?
So the Bleach 1,000 Year Blood War arc.
Sir, I'm not a fan of a bleach.
Bleach, okay. So no. Okay, so sorry for that. Sorry for suggesting me that. Right. Okay.
No, 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 no.
But but this,
Okay, but it's to
yeah,
watch. That's why I'm like, right.
yeah. It has how many? So 14 seasons and then 16 and then this one 1,000 Year Blood. So it is a very long, right?
Yeah,
So you just prefer the short ones.
yeah. Most of the time.
But they are but then you miss the big threes, right? Naruto, Bleach, One Piece.
Naruto I watched.
Naruto you watched, right? Yeah. So and it is also getting interesting. This Boruto one, so this is now getting interesting. Uh, from the time skip, so similar to the Naruto one, Shippuden one, when there was time skip and then Naruto returns from this time skip. So then that season becomes interesting. So this is going like that one. Okay, so focus. The exam is near, and we have to focus, right?
Yes, sir.
So can you tell me where did we reach in our previous class? Did we completed this Coulomb's law?
No, sir. I just we were at. Um,
I thought we finished vectors and then we started this. Where were we? Did we finish this Coulomb's law? We completed those conservation of charge, all those four basic properties we learned, or did
yeah.
we on? Yeah. So after that basic properties, there is this Coulomb's law. So did we reach that?
No, sir.
Okay. Okay. So we are very
We.
far. We are very far behind. Okay. So I have prepared something for you, right? So that will help, and I will send the actual notes based on those things. So let me share that, and that will. So this is a short trick that will help, but we will do it in more proper manner in our class, right? So, but just for the 4th June part, we will follow that. Okay,
Okay, sir.
so that you get something, because doing all those. So how many chapters are coming in your exam?
3 chapters, sir. One to
Three
three.
chapter. Okay, three chapters. So to do those three chapter in these 3 or 4 days, that would be impossible, right? Mission impossible. So
Yes.
yeah, so let us do what we can do in this very very short time. Okay, so let me share my screen, and I will send you the notes there, right? And the questions that you need to do it by on your own, right? And then whenever you find any problem, then you ask. Okay, oh, so this is you. Yeah. So let me. So this I will share with you along with the notes that I'm going to make for you. Okay.
Okay, sir.
Yes, so this is about what are the derivations that they may ask in your exam, right? So how much marks is for the derivation in this test? Maybe five, above five, right?
Yes, sir.
So these are some set of derivations that they may ask, right? Uh, so you have these three chapters, and these. So just ignore all the rest ones. So up to this 1 and 2 units, okay, these are the derivations in the electrostats. So Coulomb's law in vector form, right? I haven't taught you all these, so you have to bear with the derivation part, right? Okay.
Okay, sir.
So these are, I will share the PDF with you. Okay. So these are the derivation, Coulomb's law in vector form, electric field of a point charge, electric field of a dipole, axial and equatorial point. And then we have this torque on electric field in uniform field, right? So, and then you have this application of Gauss law and then this potential. So these they may ask. And then in current electricity, drift velocity, relation between currents and drift velocity, Wheatstone bridge principle and series parallel and mixed combination of identical cells. So these are few, not few, but these are the derivations. Okay. So what I will do is that I will make notes of these derivations, right? And then you go with all those derivations. Okay.
Okay, sir.
So, but we will do this in proper manner in our class after 4 June. Okay.
Okay, sir.
And then I will send you some questions also. So please do those questions also. Then I guess then you would be able to score good marks, at least good marks. Okay. Yeah. So,
Yes, sir.
but I haven't taught you this Coulomb's law in vector form. So what should I do? Let's start at some point, right? You first, I will send you the notes and you go through the notes, and whenever you find any question, any query, any doubt, so ask me that. Okay. Yeah.
So where are you going to send it to me?
So in your WhatsApp number, right? I will send the PDF in your WhatsApp number. Okay. So
Okay.
I will send it to the operations team, and then they will send it to you. Okay. So you got the
Okay, sir.
link. So you got the link of the class from some WhatsApp number, right? So
Yeah.
I will send the notes to that WhatsApp number, and then they will send it to you. Okay.
Okay, sir.
Okay. So let us start. So cool. First, so this is the first derivation. So before I do that, I need to teach you about this Coulomb's law, right? So before I do this derivation, so first I need to tell you about this Coulomb's law. Okay, so mm, where is this? So I'm starting from the middle, but what I can do? So just bear in these 3 or 4 days, just bear with me. Just accept whatever I am saying, right? Okay, and then we will explain all those things in the later class. Yes, Aisha, finished with your test.
Yes, sir.
Okay, good, very good. So meet you the day after tomorrow. Okay, Allah Hafiz,
Okay.
Aisha.
Love.
Yes, Coulomb's law. So you have these two charges, right? So let's say that you have two charges. This is Q1 charge and this is Q2 charge. Okay. And there is some separation between them. Okay. So you know about this Newton's law of gravitation, right? Right, Sad?
Yes, sir.
So in Newton's law of gravitation, you understood that if you have two masses, right, and there is this some separation. So Newton's law of gravitation said that the force due to gravitation would be G m1 m2 divided by r square, right? So similar to this, Coulomb's stated that force due to these two charges would be directly proportional to this product of the charges. Okay. And then it would be inversely proportional to the separation square. So when you remove this proportionality, so there would be a constant term. So this constant term is K and this is Q1, Q2 by R square. So this is the Coulomb's law of electrostatic force. Right? This is the Coulomb's law. Okay, Asad.
Okay, sir.
And then you have this K is how much? So this K is 1 by 4 pi epsilon naught, where this epsilon naught is your permittivity of free space. Okay, and this value is 8.85 into 10 to the power minus 12 C square per Newton square meter square. Okay. Okay.
Okay, sir.
And are you also noting this down?
Just one second.
Okay. Okay, so just quickly note this down and then we will do that derivation, the Coulomb's law in vector form. Okay, mm, let me close that. Okay, done, Saad.
No, sir. One second.
So do you have any notes that your teacher taught you? Do you have any notes of those? Huh?
Sir, it's incomplete, sir.
So does your friend have any notes? Please ask them,
Yeah.
right?
Yeah, I have like
Yeah. Please ask
I
one of
already.
your, yeah. So please ask them and consult those notes and whatever the problem that he has done in your school. So just do those problems, right? I guess that he or she will not be asking beyond that question. Okay. If so, if
Today, sir,
yes, yes, yes.
today, sir, questions to solve. He told it will come for exam.
So that is good, right? That is a savior. So you send me those questions. I will solve those for you, and then we will discuss. Because in these 3 or 4 days, we can do that only, right?
Yes, sir.
And then I'll start from the scratch. Okay. Because I
Oh,
will rush in these 3 or 4 days, and then I'll start from the scratch. Okay. Yeah.
okay, sir.
So please send those questions to the operations team, and then I will send the answers to those questions and also the derivation part. Okay.
So I should send to the WhatsApp number which I have.
Yeah. So send it to that, and they will send. Okay.
Okay, sir.
because it is a protocol that that I should not share my personal number with you, right?
Okay, sir. No problem.
Yeah. So noted.
Yes, sir.
Yeah. So and then what happens is that you place these two charges in some medium, right? So your force is how much? So before the medium, your force is this. This is 1 by 4 pi. Oh, what does that mean? So
1 by
1 by
mu.
4 pi epsilon q1 by r square. Right. So this is the force when this is placed in the air. Okay.
Yes, sir.
Now what happens is that are you feeling sleepy?
Yeah.
Are you tired? So how many? Yeah, what should I ask? So you are sitting on the table or on the chair from how many? How much time did you spend?
No,
Yes.
just now at 5:04, I just got up from the bed. I slept for
Okay.
half an hour.
Okay. So so the what? The after sleep effects, right? So
Mm,
you didn't
power
get
nap.
your yeah power nap, but you didn't get your full sleep, right? So yeah. So yes. Yes, wake up, wake up, wake up, Saad. Wake up, Sid, wake up, Saad. Right. Yes, so when what I do is that I place these two charges, right, in a medium. So when I place these two charges in a medium, so what happens is that the force changes. Okay, so let's say the separation is R, right? So force would be 1 by 4 pi epsilon and then Q1, Q2 by R square. So this is medium. Okay.
Okay, sir.
And this epsilon is permittivity of medium. Okay. And this, so we can write this epsilon as 1 by 4 epsilon naught K and then Q1, Q2 by R square. So this is F medium, right? And we already know that what is 1 by 4 pi epsilon naught Q1 by Q2 by R square. So 1 by 4 pi epsilon naught Q1 Q2 by R square was F in air, right? So we can put this value in here. So this would be F net, F medium. This is F air by K, right? And this K is called the dielectric constant. Understood up to this point? Saad, did you understand up to this point?
No, sir. After this K value, I didn't understood.
Yeah. So this you can yeah. So let me write it in a more proper way. So
So,
yes,
permittivity of free space. What do you mean by that?
yeah. So you have a free space, right? And it has some
Yeah.
it has some electric effect, right?
Okay.
So that is called the permittivity of the free space. Okay. So that depends
Okay, sir.
upon the that depends upon this charge, this force, and this whatever is the separation, right? So this is the permittivity of the free space. But when you place those charges in some medium, so that permittivity changes. Okay,
Okay, sir.
and that changes due to the dielectric constant. So this dielectric constant changes the permittivity, right? Okay, understood. So
Ji, sir.
Yes, so this is Q1, Q2 by R square and 4 pi epsilon naught, right? And then this is 1 by Q. Okay, we can rewrite it like this. Right, Saad?
Yes, sir.
So this we know. This is how much? This is F air. Okay.
Okay.
So this would be F air by K. So that is how we get this F air by K. Now, do you understand? Right.
F air
Huh? Yes.
in air. Okay.
Your voice is breaking.
F
Yes.
air, sir. F air.
Yeah, F air. So this is F air because this value is when there was no medium in here. So when there was no medium in here, right? So when there was no medium, your force was this, right? This was F
Yes,
air.
sir.
Okay. And similarly, you can understand this. So
Okay.
yeah, so you can understand it that this permittivity is the product of these electric nature of the charges. Similarly, we have this gravitational constant, right? So like the gravitational constant, you have this permittivity of this free force. Okay, now you understand this permittivity and this F air.
Yes, sir.
Yeah, so this is how this F air by K comes. Okay. And
Okay, sir.
this F medium will be, so you see that whenever you divide, let's say this is 4 and we divide by 3, right? So this will be lesser number. Whatever will be the, let's say this is some X. So is this X will be less than this 4, right? Understood whatever what I'm telling. Understood, Saad? Yes, Saad. Did you understand
No, sir.
what I'm? Yeah. So I am saying that let's say you have some number. Let's say you have this 5, right? And let's say I write it like let's say 15 by 3, right? Understood. So you can see that this 5 is less than this 15, right? Whenever you divide with something, so the result or the number gets reduced, right? The value gets reduced. Understood.
Yes, sir.
So you are dividing with this K, right? So this F medium would be lesser than this F air. Now, do you understand this part? Yes. Do you understand this part?
Yes, sir.
Yeah. And when this criteria will hold, when this K is greater than 1, right? So let's say if this K was less than 1, let's say if it was 0.5, so let's say this is 4 and this is 0.5. So the result would have been how much? So this would have been 10 and this would have been 8, right? So 8 would be 4 by 0.5. So if this number denominator is less than 1, right? So then this number would be greater. But K is greater than 1, right? So that's why this F medium is lesser than air. Understood? Yes, did you understand this part, Saad?
Yes, sir.
Yes. So the force will increase or decrease in the medium. What do you find out from these calculations? So the Coulomb force will decrease or increase in the medium. Yes, Saad,
It
any
will.
guess? Yes, it will.
Increase.
You see, this is less, right? So this is less than the air. So this will decrease, right? Because this is dividing. From this factor, it got divided. So the force in the medium,
Decreases.
yeah. So force in the medium decreases. And how much it decrease? So it decreases by K, and which is dielectric constant. Okay, so this is the point to make. Are you noting from some point? Where should I put the screen?
Yeah, sir. Can you little down?
Little down.
Yeah.
Is this?
Enough.
Yeah.
Sir.
Okay, so then I will do the derivation. So now you know the Coulomb force, then we can do the derivation. So do you recall any vector? So do you remember the vector class from the 11th? You forgot or you remember?
Sir, I didn't study it, sir.
Oi, oi. Then I need, so to do that derivation, I need to tell you about the vector part also. And we have this, okay. So, so you have to memorize only, right? Without understanding for the sake of this exam only, just for the sake of this exam only, you have to just memorize, okay?
Okay, sir.
And then after the exam, we will understand everything, okay?
Okay, sir. Inshallah.
Inshallah, inshallah. Amin, amin. Yes, so noted.
Yes, sir.
Yeah, so okay, vector. Okay, so I will do the vector after the exam. So let me just derive derivation one. So this is Coulomb's law in vector form. Okay, so let's say that you have this coordinate system x and y, right? And these are the two position vectors of, so this is some r1, right? And this is some r2. So this is position, let's say this is, so let's say this is P point and this is Q point. And the position vector is this r1 and this r2. This is the position vector, and this charge is q1, this charge is q2. Okay, and
Okay, sir.
the separation vector would be this. So this is the separation vector. So let's say this is the vector which is r1, right? So there is this triangle's law which says that if you have this vector and if you have this vector, so let's say this is A and this is B. So this would be this would be A plus B. Okay, this is
Yes,
the
sir.
triangle. So you have this R1, right? You have this R1 vector and this R12 vector. So your R from triangle's law, R1 vector plus R12 vector would be R2 vector, right? So the separation, yeah, so the separation vector would be R2 minus R1. Okay, understood.
Okay, sir.
And the direction
Yes,
of
sir.
this R12 vector is this. So we represent the direction of the vector by the unit vector. So this tells the direction of the vector. Okay. So the direction of this unit vector, would be this R12 hat, right? And this would be how much? So we can calculate the unit vector. So this is vector and this is magnitude and this is a vector. So the direction a vector can be calculated by dividing the vector by its magnitude. Right. Right. So the R12 hat would be R2 minus R1 vector divided by R2 minus R1 magnitude. Understood this much? Yes,
No, sir.
no. Okay. Okay. So should we learn about this vector first? What should we do? Okay. So just let us start from the beginning. Just keep it this way and then just start from the vectors. Let me recap vectors. Okay. So vector has how many parts, Saad? Yes, vector. So there are two kinds of physical quantity. One is the scalar quantity, other one is the vector quantity, right?
Yes, sir.
And a scalar quantity can only be represented by the magnitude only, right? So we
Yes, sir.
can, and the vector quantity can be represented with the magnitude as well as the direction, right? So there are two parts of a vector. One is this magnitude and the other one is this direction, right? So you can represent any vector by its magnitude and its direction. So this part, this A hat, so this part tells about the magnitude and this part tells about the direction. Okay, so this is called the unit vector. Why unit vector? Because its magnitude is, as the name suggests, 1. Right, so it only represents the direction. Understood, Saad? Yes, understood.
Can you, sir, can you explain the unit vector again?
Yeah. So you have these two parts of a vector, right? Magnitude and direction. Okay.
Yes, sir.
So this this can be represented by a vector can be represented by this magnitude, right? And this only shows the direction, this unit vector. Okay. Because if it had some magnitude, then this, so there would be two magnitudes, right? So we calculate all the magnitudes and we incorporate in this part only, right? And this part only tells about the direction. Okay. So that's
Okay,
why
sir.
this is called the unit vector. That's why this is called the unit vector and it has the magnitude which is 1. Okay. Understood.
Okay, sir. Yes, sir.
Okay, when you learned about this universal unit vectors, then you know, right? Let's say that in x direction you are moving, right? So you are moving in this x direction, and you move 1 unit in the x direction. 1 unit meaning magnitude is how much? 1, right? So this will be called the I hat. Okay,
I
under
had.
yeah, in x direction, right? So
Okay, sir.
you move 1 unit in x direction, right? Let's say you move 2 units in x direction. So that would be I plus I, so that is 2I, right? And let's say that you have moved 5 units in x direction. So this vector is 5I, right?
I,
So this vector has two components. This is the magnitude, right? This is the
okay.
magnitude, and this only tells about the direction. So this I hat represents that it is moving in the x direction, right?
Okay, sir.
So yes, I am feeling that you have a doubt. Yes, any?
Sir, I,
Yes, I.
what's that, sir? Is it just a variable?
No, I is a unit vector. I is a unit vector which represents that we are moving in the x direction. So let's say we have three coordinates, right? So if we move in the I direction, then this is I hat. In the x direction, it is I hat. If you move in the y direction, so that is called the j hat. These are convention, right? These are convention that represents the direction in unit vectors. So if you move in the z direction, so that is called the k hat. Okay. So let's say a person is moving 3 steps, 3 units in x direction, and let's say 2 units in y direction. So we can represent a vector which shows the position of this vector. So this is 3 comma 2 point, right? This point is
Yeah.
3 comma 2, right? So we can, so with vector, we can represent the position vector. So this would be 3i plus 2j. Understood? So this
Yes,
yes, yes, yes, boss.
yes, sir, done. I understood.
Yeah. So this is how you represent the unit vector. So these are this I, J, K. These are the conventions, right? And they are called the universal unit vectors. So this I, J, K are universal unit vectors. Okay. So from here we can see that we can write any vector. We can write any vector in the form of these universal unit vectors. So you see that this tells about the x component. So here you see that this is the x component. This is the y component, and the z component is 0, right? So we can write any vector in the form of universal unit vector form. Okay.
Okay, sir.
And here this ax is x component of the vector. And you have this y component, and then this az, which is z component. Okay. So let me again reach from where we started the vector part. So vector has how many parts, Saad?
3 parts.
Ah, vector has, so what is the third one? One is the magnitude, second is the direction. What is the third one?
Sorry, sir, sorry, sir.
Yes.
I got the direction, sorry.
Yeah, so do not get confused with these components, right? So yes. Yes, so you see that vector has 2 parts. So one is the magnitude and the other one is
And
the direction, right?
yeah,
So whatever vector is given, so this is the given vector and we have to find the magnitude, right? Find the magnitude and the direction. So we can find the magnitude of this vector like this. So this would be ax square plus ay square plus az square. This is the magnitude. Right, sir?
yes, sir.
Do you remember this part?
Yeah. Yes, sir, I remember.
Yeah. And then you can calculate the, so A hat represents the direction, right? Right, na?
Yes, sir.
So how can we calculate the A hat? Your vector is this. So this is the vector. This is the magnitude, right? So we can
Yeah.
calculate this unit vector by how? So your A hat is A vector divided by this A magnitude, right?
Yeah.
So this unit vector would be A vector, which is AXI plus AYJ plus azk, and divided by this magnitude, which is ax square, ay square, az square. Okay, so this is the direction. Now we
Yes, sir.
calculated the direction, and then we calculated the what? The magnitude.
Ma- Okay.
Okay, so this is about this vector in the universal unit vector form. Okay,
Okay.
so we will need only this part. So let's say that you have these two vectors. Let's say you have this vector which is at this is our 4 comma 2 point, right? And let's say you have this vector which is 3 comma 4 point, right? So what would be the position of this vector? This is 3i plus 4j, right?
Yes, sir.
And this vector is how much? 4i plus
2J.
2j, right? So these are the two vectors. And we have to find the separation. So this is the separation. And as I said that we can find the separation, right? So this is, we know that, let's say this is x hat. Okay.
Yeah.
So let's say this is R1, this is R2, right? So from the triangle's law, R1 plus x hat would be R2, right?
R2.
So we can calculate this x by R2 minus R, right?
R1. Yes, sir.
So this would be how much? This would be R2, we know this is 4i and plus 2j, right? And this is minus of 3i plus 4j. Okay, so 4i minus 3i is I, and
I
2j minus 4j is how much?
minus 2J.
Minus 2j. So this is the position vector or the displacement vector of this point. Okay, this is 1 point, this is 2 point. Now do you understand? So this is the
Yes, sir.
displacement vector.
Okay, sir.
Now, only this much we will need to derive this Coulomb's law in vector form, right? So there is this parallelogram's law and all those things where your magnitude is this a square plus b square plus 2ab cos theta. But this we will learn when we need that part. Okay.
Okay, sir.
So now let us understand this part. So do you want to note this down? Note down this part. This you know, right?
Okay, sir.
If you want to note down, then please note down. If you remember them, that's okay. What do you want to do?
No, it's okay, sir. I remember. I will remember.
Yeah. Okay. So now let us understand this first derivation. This is Coulomb's law in vector form. Okay. So as the previous diagram, right? So we have this is x, this is y, right? Oh,
Yes,
and
sir.
we have two charges placed in this plane. Okay, so this is q1 charge and this is q2 charge, right? So the position vector of this q1 charge is this r1. Okay, and the position vector of this q2 charge is this. So this is r2, and this is the separation. Separation vector is r12. Okay, understood, Saab.
Yes, sir.
And the direction of this r12 vector would be this, right? R12 hat. Now you understand, right?
Yes, sir.
So this R12, as we have calculated, this would be R2 minus R1. Okay.
Yeah.
So, and the hat part would be how much? This would be vector minus the magnitude. Right.
Yeah. Yes.
So always remember that we can't do it like this. So this magnitude would not be R12 minus R1. Just keep in mind that, right? And how can we prove that? So, so you see that from here we can prove that. So X, we want to prove that X magnitude would not be equal to R2 magnitude minus R1 magnitude. This is I want to prove, right? This is I'm saying, right?
Yes, sir.
So X magnitude would be how much? This is 1 square plus 2 square, right? So this is 1 plus 4, this is root 5. And this is how much? R2 magnitude is, where is R2? This R2 is 4 square plus 4. So 16 plus 4 is 20. So root 20 and minus of, this is how much? 9 plus 16, right? So this is 5. So root 20 minus 5. So this is not equal to this 5, right?
Yes, sir.
So this is what I was saying that this, okay, so this is not equal to this R2 minus R1, right?
Yes, sir.
Okay. Yes, so this is the separation vector, right? We only need that separation vector. And we want to calculate the force on 2, right? So force on 2, charge 2 due to 1. And this is the vector. Okay. So this would be how much? This would be K Q1, Q2 by the magnitude of this separation vector, right? So
Force to 1.
force on 2, force on charge 2
Okay.
due to
And
this,
1.
due to what? Due to this one charge. So this charge will try to repel this in this direction, right? This is the Coulombic force. So whenever you have these two charges, right? So these uh, this charge try to repel this charge in this direction. So this is F21, right? And if we want to calculate the force due to on this charge, due to this charge, so that would be F on 1 due to 2. Understood?
Yes, sir.
So yes, so this is what I am calculating. Force on charge 2 due to this charge. So this would be in this direction, right?
Yes, sir.
So this would be R12 magnitude square, right? KQ1 Q2 by R square, right? And the direction of this force is in which direction?
Hmm.
Yeah, see this direction.
I.
R12 hat, not I, right? Because the force is not in the X direction, right?
Let me show.
Yes, so R12 hat. Did you understand this part? Right, this is the direction of the force. So this is the direction of the force, right? Right.
Yes, sir.
So this is in this direction, right?
Yes.
Okay. And we have calculated what is this R12 hat. So we can write R12 hat. So R12 hat is equal to R12 vector and divided by R12 magnitude, right?
Yes, sir.
So this is square and this is 1. So this would be how much?
Cube.
Right. So this is cube and this is R12 hat. So this is the force on charge due 2 due to 1 charge. Okay, this is the Coulomb's law in vector form. Right, this was easy, right?
Yes, sir.
Yeah, so please note down this part and yeah, so where should I? Yeah, so this is it.
Yes, sir. Noted.
Oh, you already noted.
Yeah, I was writing with you.
Ah, yeah. So, and then again, so this due to the Newton's third law. So whatever this guy is pulling in this direction, so the same will apply to this. So if this is F21, so F12 would be in this direction, right? So F12 would be negative of F21, right?
Yes, sir.
So this would be negative of K Q1 Q2 by R12 Q, and this is R12 hat. So let's say that this is some A vector, right? And negative of A vector would be how much? This would be minus A in the opposite
Minus.
direction, right?
Yes, sir.
So this is R12 and negative of R12 would be how much? R21, negative of
Yeah.
R2, right? So this would be how much? So this would simply be K Q1 Q2 by R12 and Q and R21. So for the convention, we can write this as magnitude are similar, right? So we can write this as 2, 1. Ah, don't sleep, right? I am not that boring, you know.
No, sir, you're not.
Yes, yes. So please note down this part. And you see that whenever you want to calculate the 2, 1, then the vector would be 1, 2, right? So just remember that. Okay.
Okay, sir.
Yes. Yeah. So one more thing we can write this. Right. So we can write this like this also. So remember your R21 is R1 minus R2. Right. And
Yes.
this is R1 minus R2 Q. Right. So you can write this way again also. Okay.
Okay, sir.
Yes, so one derivation is done, and we should do one question based on this. Let's say that two charges, right? So no, you noted this part.
Yes, sir.
So let me give you one question, right? Let's just take this question and okay, so one I should do and then give you the homework. So let's say that the position vectors are given, right? Position vector is let's say this is so let's say this is 3i, let's say this is 3 comma 4 comma 5, right? And let's say this charge is let's say 2 comma 4 comma 7. Okay, so these are the position given of two charges, q1 q2. Q1 is let's say 5 let's say micro coulomb, right? Q2 is let's say 3 microcoulomb, right? So I want to calculate what is the force on 2 due to 1, right? This is R1 and this is R2. Understood? Okay,
Yes, sir.
who has come? What, yes. Yes, so first we need to calculate, so just check this formula. Oh, who left? Okay. So first check this formula. We need to calculate R1, R2, right?
Yes, sir.
So what would be R1 here? The
2.
position. Just look. So R1 vector would be how much?
2I plus
Yes,
4J
yes, sir. Yes, sir.
7K.
Right. And R2 would be 3I plus 4J plus 5K. Right.
Okay.
So we need to calculate this F21 would be how much? This would be K Q1 Q2 by, this is R1 minus R2 cube and then R1 minus R2 vector. Right. So what would be
Yeah.
R1 minus R2? This would be 2 minus 3, so minus I, 4 minus 4, 0, 7 minus 5, 2K. Right. So this is minus I plus 2K. Right.
Okay, sir.
And what would be the magnitude? So magnitude of this vector would be 1 square plus 2 square. So this is root 5. Okay.
Okay, sir.
So what would be this F21 vector? So this would be K, which is 9 into 10 to the power 9. Q1 is 5. Micro is how much?
Uh, 10 raised to minus 9.
Oh, that is nano.
Oh,
Micro is minus 6, right?
okay, sir.
And then this is 10 minus 6. This we know this is minus I plus 2K, right? And then this is root 5. And then this is cube. Right. So this is, this cube is 5 root 5. So minus 6, 3, 10 to the power minus 6, minus I plus 2K. And this is 5 root 5, 5, 5 can, okay, where is this 5? So 5, 5 cancels and we have 27, 27 by root 5, 10 to the power minus 9 and 6, 6, 12. So 9 minus 12 would be minus 3 and this is I plus 2K. Understood, sir. So this would be the force. Okay.
Yes, sir.
Yeah. So let us,
It's clear.
yes, 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 sir. Did you say anything?
Yes, sir. I told you it's clear. Like
Yeah.
it's been easy.
Yeah. Yeah. So let us stop at here and then I will send you those. So please send me those questions and then I will solve that and I will send it to you. Okay. Along
Sir,
with the,
I already sent it to Learnivio view.
oh, you, okay. So you already sent it to, okay. Just now.
I know 5:30.
Okay. At 5:30. Okay. So then I will
Sorry.
cut.
KSA time.
Oh, KC time. So 5:30 is 8 o'clock, right?
Okay, sir.